Welcome all of you to this video of Maths Made Easy. Now we are going to do electrical power and energy questions today. Okay, so I'm going to take up few questions of electrical power and energy. So these are the sums which are based on Joules heating effect, or they are based on all those formulae that you have for power, that is P is equal to VI or V square by R, all those. So you will see all of them here, and what is most important is, as I proceed with the questions, all of you please keep noting the way I am calculating. I am calculating with the fastest possible method, least calculation method. Okay, so just keep noting my method of calculation. Okay, so we'll start here now. Here is a question which says water in an electric kettle. It's connected to 220 volts. So the very first thing is we note the voltage 220 volts. Okay, and it takes 5 minutes to reach its boiling point. Okay, so time is 5 minutes. Time is 5 minutes to reach its boiling point. How long will it take if the supply voltage is changed to 200 volts? Now note one thing here, we have changed the supply voltage suddenly. Okay, if the supply voltage changes suddenly, the current will also change. So if the voltage changes, current will change, and so the time will also change. So this is based on this. Now there is a trick in the sum that you have to understand. Now in 5 minutes, how much of heat was produced? The same amount of heat will be required to bring the water to its boiling point, even when the voltage has fallen to this. So what remains constant is the amount of heat required to make the water boil. Okay, so we'll start. So firstly we'll do H. From Joules heating law we have, so H is equal to VIT, you know this. Now I don't have any value of I here, I don't have the value of current. So what to do? V into V by R. Yes, V into V by R. I is equal to V is equal to IR. So I is equal to V by R. I have used this over here into T. Okay. Now V is 220. 220 into 220 into T. T is 5. Okay. T is 5 minutes. But then let me convert it to seconds. Okay. And then I have R. Now R, do I really know R of this circuit? Do I know the R of the kettle? I don't know R of the kettle. Okay, so what to do here if I don't know the R of the kettle? Okay, so here I will just, I'll just leave it like this and I will not do any calculation. Okay, so this is the heat that is required to bring the water to its boiling point at a resistance R. Okay, now let me proceed with the calculations. Now this is the second case that we are going to do now, when the heat required will be the same, and then we'll have VIT once more, but this time the V is going to be different. So VIT definitely once more, but then V is 200 and I is again V by R, which is 200 and by R. Okay, and T is, we don't know time. Okay, so we'll just leave it like that, T. Okay, that T will come in seconds because here also we have taken it in seconds. Now this heat is equal to this. Now let me tell you one thing, if I used here R, I have used here R as well. This is the fastest possible method of doing this sum. Okay, if I've used here R, even here I have used the R. Why? Because the kettle is not changing. Now this is one concept on which they make a lot of sums. You'll see that they are making a lot of sums based on this. The bulb is same, the voltage differs. The current will differ, but the resistance will be the same. Same thing here, the voltage is differing, the current will differ, the time will differ. But what will not differ is the resistance. So if we are using R here, because resistance is something which is based on the coils of the kettle, the coils of the kettle are not getting changed. Okay, so here R here R. The same R we are using on both sides. So even without knowing R, we can complete the sum. Now the heat produced in the second case is given like this, heat produced in the first case is given like this. But then remember one thing, that the water has to come to the boiling point, it requires the same amount of heat. So we have 220 into 220 into 5 into 60 by R, which is 200 into 200 into T by R. R and R gone. Okay, this is gone. Then 2 with this 11. Okay, then this 5 with this 4, 2 with a 2, this is 11. Okay, so now we have T is equal to 121 into 6 by 2. Now this value that we have got is in seconds now, because this was in seconds, here time was in seconds. Now what we will do now is we will divide it further with a 60. We'll divide it further with a 60. Why will we divide it further with a 60? Because if we divide it further with a 60, we will be able to convert it to minutes. So this is 10. Now, how much is it? 121 by 2 is a 60.5. Okay, divided by 10, that is a 6.05 minutes. Okay, so that is my answer. This is our next question. An electrical toaster draws a current of 8 amperes in a circuit with source of voltage 220. So the voltage, the first thing we note down is voltage is 220. Okay, and it is draws a current of 8 amps in a circuit. So I is 8 amps and it is used for 2 hours. So time is 2 hours. Now what is the cost of operating it? At rupees 450 per kilowatt hour. Okay, so with the very first thing that we do here is we will use Joules heating law. H is equal to I square RT, right? So H is how much? Now H is, first thing we'll find the heat produced. Okay, how much of heat it is producing in 2 hours. So how much of heat it is producing? First 8 into 8 current. Resistance is, we don't know resistance, so we'll use V by I. Okay, so V by I, if I use 220 by 8 and then time is 2 hours. Time is 2 hours is 2 into, time is 2 hours is 2 into 2 hours means 2 into 60, that makes it minutes into 60. Okay, 2 into 60 into 60, that makes it into, now 2 hours is, first this is 120 minutes and then into 60 is the number of seconds. Now we shall start calculating this. We'll get the amount of heat that is being produced. Then we'll talk about the cost. Just cancel. Okay, so how much do we have now? So we have 8 into 220 into 2 into 60 into 60. Remember one thing, आप जितना कैलकुलेट करोगे उतना ही आपको गलतियाँ होने लगेगी. तो इससे अच्छा है कि आप ज़्यादा मल्टीप्लाई ही मत करो, आप ज़्यादा कैलकुलेट मत करो, बस इसको कॉपी कर दो. और इट इज़ यूज्ड फॉर 2 hours. कॉस्ट ऑफ ऑपरेटिंग इट एट रुपीज़ 450 पर किलोवाट आवर. अभी जो ये वैल्यू आया है ना, दिस हीट, this is actually in joules, because when we use I square RT, this T is in seconds. If this T is in seconds, we get the value in joules, but they wanted kWh. What to do? We will divide with 3.6 into 10 to the power 6. Okay, 3.6 into 10 to the power 6, if we divide, it gets converted to kWh. Okay, now here 8 into 22 into 2 into 36, I am taking all the numbers here and the zeros separate. 10 to the power 3 by 3, 36 into 10 to the power 5. I remove the point. 36 with the 36 got. Here I will be left with 10 to the power 2 here. Okay, so this is 16 into 22. Okay, 16 into 22 by 10 square. Okay, so 16 into 22 by 10 square, that many kWh, kilowatt hours. Okay, but now the cost is 16. Still see, you can note, still I have not multiplied. Okay, still I have not multiplied and divided. Now this is 16 into 22 by 100 into 4.5 rupees for every kilowatt. So I'll write a 9 by 2. Okay, that makes it 8. Okay, so if I calculate this, I get a total of 15.84 rupees. Okay, so this is my final cost. So what is the trick in this sum? The trick in this sum is not to calculate at all. Okay, what we have to remember in this sum is, if they have given it in kWh, we have to first convert it to kWh. So by dividing it here, I converted it to kWh. So the moment you get numbers, don't start multiplying. Okay, now here once I have got it in kWh, then I multiplied it with, and here also I avoided decimals, so 4.5 I made 9 by 2. Okay. Now here is our next question. An electric iron is rated at rupees 220 volts. So it is 220 volts and it is 2 kilowatts. Power is given, volts is given, used for 3 hours daily. Find the cost if it is run for 1 week, and the rate is also given. Okay, so here remember one thing, power is, see, we know this power, whether it is electrical power or mechanical power, power is energy by time. Power is energy by time. Now energy is, here in this case, is heat energy. So heat or energy is power into time. Now power is 2 kilowatts. Okay, and time here, since it is already in kilowatts, I will write this in time is 3 hours. Okay, and that it is being run for 7 days, 1 week. Okay, so this is the total amount of heat that is being consumed in 1 week, and this is coming in kilowatt hour. Okay, now this is already in kilowatt hour. Why? The time we have taken the time in hours, and this is already in kilowatts. Okay, now we'll not proceed with this anymore. We'll just write kilowatt hour here. Now cost that is involved is into 7 into 4.25. Okay, so if we multiply this, we have 42 into 4.25. 42 into 4.25 gives a 178.5. Okay, so that is 178.5 rupees. Rupees 178.5 is the cost. Now what happens in these sums, the moment you see them, it becomes little confusing because there are so many things involved in it. So here, if they are talking about power, and power is in kilowatts, and if you want the energy to come in kilowatt hours, then the first thing you do is you take the time also in hours. So here in this sum, I did not make any effort to change it to in seconds or minutes, because I know that at the end I want it in kilowatt hour. Okay, because the cost is given in kilowatt hour. Now here is a question. A geyser is rated at, so the power is given as 1500 watts. Immediately as you see the sum, right, voltage is 250. Okay, this geyser is connected to 250 volts, means calculate the current drawn. Now P is equal to VI. So V is 250. V is 250. and I we don't know, and P is 1500. So we are going to get I as 150 by 25, which is 5, and this is 30, which is 6 amperes. Okay. Now the energy consumed in 50 hours. How much of energy is consumed in 50 hours? So energy is again power into time. So power into time. They have told 50 hours. Now the energy, that is power, is 1500 watts. Now remember, the time is given in hours. Okay, so it has to match. So if the time is given in hours, we will first convert this to kilowatts. Now I made it into kilowatts and now into 50. Okay, so see, I'm just cancelling 75 kilowatts. Okay, kilowatt hour, sorry, kilowatt hour. Then next is the cost of energy consumed at rupees 4.2. How much of energy? So what is the cost? Now the cost is how much? Cost is at rupees 4.2 per kilowatt hour. So all we have to do is multiply 75 with 4.2, and that will come to rupees 350. Okay, so that is rupees 350. So this is how we do power questions. So I just took a few questions trying to show you how to do this work, energy and power type of questions. How to do, these are the sums which are based on Joules heating effect. So how to do these questions. So if you have liked the video, do not forget to like, share and subscribe. Okay, and you'll find you'll find more videos of electricity. I have uploaded a lot of videos in electricity, all types of questions. This was my last video in electricity numericals. You'll find them in the playlist. So please check the playlist. Also, you'll get the links for the playlists in the description box. Thanks all of you. Bye then.